All right, so looking at these a little more before we go on to our next stuff in this unit, let's look at the four ways to lift the atmosphere to produce precipitation. Remember, lifting the atmosphere cools it, and if it cools it off enough, the temperature of the atmosphere reaches its dew point, and you get condensation, and from that then follows sometimes precipitation. So lifting is the key to cooling, which is the key to formation of precipitation. All right. So, in looking at these, first of all, let's look which ones of these are seasonal in nature. Is orographic precipitation seasonal? Is there something inherently different about summer and winter, about the mountains or higher elevations versus lower? No. Okay. So, that said, then, though, places where we get orographic precipitation really pronounced in Oregon are the mountains, upslopes, and we have those in a lot of parts of the states. But they are associated with typically the frontal systems that come in, and those are warm and cold fronts. And they come in mid-latitude cyclones, which are low pressure systems. And then those frontal boundaries, like cold air cutting under warm air, will lift the atmosphere. So we get a low pressure system comes through, it pulls in moist air off the ocean. We get orographic precipitation or enhancement associated with that. So a lot of these are really combinations of more than one thing. The mountains are always there, but the low pressure systems come and go, right? And the low pressure systems bring fronts with them. So in a sense, when you get more precipitation in the mountains than in, say, the Willamette Valley, and it's fall, winter, early spring, we can say that it's a combination of low pressure systems, which we call mid latitude cyclones here. That's what we get. The lows that come in are bringing with them frontal boundaries and the lifting associated with those low pressure systems. And between those fronts, which are just boundaries between different air masses, the cold air undercutting warm air is the easiest example. All of these happen together. Convectional, usually not so much in those systems. Sometimes, but not usually. Okay, so there is a little bit of a seasonal pattern, but also it's just embedded in our geography. Do we get convectional precipitation? Dominantly, it's in the late spring, summer, early fall, and it's usually on the other side of the Cascade Mountains. And that's mainly because we have a dominant high pressure cell much of the summer and early fall and even late spring over Western Oregon in the Pacific High, which is offshore. So it really influences our area and keeps the air kind of sinking rather than rising. And that's not conducive to precipitation. All right. So the map of precipitation that if we look at the kind of world patterns, we've done this now with temperature, we've done with insolation, incoming solar radiation. So where's it wet? The green are the wet areas. So greens, browns are fairly wet as well, but especially the greens, or especially dark greens, are the wettest of all. That's kind of an easy pattern to remember, isn't it? It's basically tropical. Tropical precipitation is where it's heavy the most. Okay, so that's generalization one. But then we see some other things going on too, and we'll come generalize on those later. But you can see some kind of pretty dark green areas here and there. And interestingly, they're about the same distance from the equator, aren't they? Yeah, what's going on there? And maybe to some degree here too. So these are onshore, they would call those the orographic precipitation zones or coastal littorals, the term we used earlier. We see those in the mid latitudes. Those are those mid latitude cyclones bringing in, frontal systems, lifting the air, the low pressure that brings them in. Those are the storms. Give those areas a lot of precipitation. And then there's some moderately high areas, even getting out of the tropics. You can get into Japan, um, East Asia in general, even out of the tropics is this way, and the East Coast, Appalachia, and so on in the United States is that way too. So there's kind of an extra tropical pattern as well. That's mostly East Coast, not so much West Coast until you get farther north, right? California, except for the northern part, is pretty dry. So that's the general pattern of where it's wet and where it's not. Um, Wow. Yeah. What's going on? It's cold. It's now we know this. Cold air cannot hold much moisture. So that's the single simplest reason for why Antarctica has less than 10 inches of annual precipitation. Most of the polar zone north of the Arctic Circle is the same way, with a few exceptions. These are the Ural Mountains, but pretty much that's the pattern there too. And then we've got the subtropical high dominated pressure region of southwest US, northern Africa, Middle East, southwest Asia, dry. These are dry places, as are the subtropics, mostly here and here and here. So subtropics tend to be dry, especially west coast sides of them, Australia, southern Africa, kind of South America that way. Again, west coast of Africa is that way. Excuse me. Um, so kind of well, there's several things happening, but there's these interior deserts in these middle latitude areas like the Gobi Desert and so on. And then there's just areas dominated by the subtropical high pressure. Remember, high pressure is sinking air. Air sinks in high pressure zones. And when you have high pressure, then instead of the air rising, cooling, and therefore being able to form precipitation, you have just the opposite. The other piece is, hey, now these areas are far away from oceans. Yeah, there's some internal seas, but not enough to make a huge impact on the climates. And so they're isolated from moisture. And so these internal deserts, like the Gobi, for example, are dry as well. And much of Africa, the air circulation pattern for a lot of the year is not off the water coming to the south. These are very dry, and even though they're near the Mediterranean, they're kind of, especially in these areas here, they're isolated from the large ocean basins. So very dry there, and dominated by subtropical highs. All right, let's go look at that in more detail, just in writing it out, what I've been saying. So general pattern, so high pressure, the subtropical highs favor aridity on the west coast, and low pressure favors precipitation. So kind of higher mid latitudes like British Columbia, southern Alaska, and us during our winter would be cases of that. Um, Areas of great precipitation, then the one thing we noted, the whole tropical, or rather equatorial zone, where you have the convergence zone, and then the related monsoon lands, say of South Asia, close by India, for example, Southeast Asia. We talked about those monsoon lands earlier. The zone of the subpolar lows, so we get those coming through in our winter and then not so much in the summer. The littorals, the third time I've used that term to kind of help you learn it. It's a coast that has moist air coming on shore, like our own west coast here, but also places that are located in the trade winds, which remember are tropical mostly and a little bit subtropical in their latitudes. Hawaii is a place where the trade winds blow like this. So this is Hawaii here, okay? And so the trade winds blow onshore. They're from the northeast there. And so as they hit Hawaii, if this is Hawaii here and the trade winds are coming in, um, it's wetter on this windward show, the littoral show, as it were. And having a quick look at the map of North America here. This is a great little atlas, by the way, and you have access to this just like I do. This is a map of precipitation of our North American region, a little more detail there. And you can see the coastal littoral pattern. All of these areas have that onshore flow of moisture. Those subpolar lows come in with their associated fronts. We call those mid-latitude cyclone systems as they break off those lows. And what happens is this whole coastline here all the way to central California is fairly wet, especially in the winter down in this area. Here, the maximum isn't so clearly winter, even late summer, early fall up in these areas. And so these are onshore flow of moisture. Interestingly, Central America here, this is a trade wind zone. Remember your diagram? So trade winds, look how it's wetter on this side. Okay, so trade winds keep this coast, and along Mexico true as well. Trade winds keep these coasts wetter. Trade winds are coming in this way from the northeast. Okay. By the way, this is kind of a fun map. You can look at some other things here too. Look at this. That won't work. My luck. So yeah, that's a temperature map just so if you want to play around with that a little bit, there's some fun things you can see. It's like a little GIS, almost kind of an atlas. All right, so let's get back then to our slideshow on that. we are on this precipitation pattern thing. So that's just a quick look at our own patterns here with North America. So the west side of subtropical ocean highs those high pressure cells, like for example, in the United States, if you go like to Florida, Georgia, and so on, there is a subtropical high off of their ocean too. But when you are on the west side of that high, which would be the eastern U.S., since it highs over the ocean, these are areas where it is moisture. So whether it's Japan, northern China, Korea, or eastern United States, there is a subtropical high over that ocean basin, but it's wet there anyway, and it's partly just because the circulation around that high brings moisture on shore in those areas. Whereas in our case, with the Pacific high in the summer, not so much. You'll get a lot of moisture on shore, and it's a cooler ocean aside from that, so not as much humidity in the air when it gets here. Okay, as I just mentioned right here. So yeah, and our own coast in the summer, we have a Pacific high that dominates most years, and that keeps it dry. The air is sinking, and mostly the winds are from the north or northwest, so they don't really circulate very much on shore. And the cold ocean, anyway, that we have, for reasons we'll describe later, um, gives us a pretty dry summer. So the areas of low precipitation are many, and I talked about some of those already. Let's go back and look at it real quickly, though. So this is a dry area, the Atacama Desert and the Peruvian Desert. Wow, subtropical high dominated here. This is a subtropical high dominated coastal desert region. Oops. This is a subtropical high dominated coastal region. So is Perth, Geraldton, these areas of Western Australia. Subtropical high dominated, as is this area here. So if you're in a subtropical high dominated west coast, it's dry. And in fact, it's a desert for much of the year. The Central Baja Desert gets 2 to 4 inches of rain a year. Some years nothing, some years 10, with remnant hurricanes and so on. Very same kind of dryness in Southwest Africa, and up to about right here with Chile. From here on northward, it's the Atacama Desert, one of the driest deserts in the world. There's parts of the desert that don't get rain for literally years and years at a time. Very dry place. All right. The rain shadow deserts like the Mojave and Sonoran Desert in the interior, like if you go to the mountains of Southern California and Baja, if you go into the interior of that, like into Arizona, that's Mojave, Sonoran deserts. Those are dry interior deserts, rain shadow deserts. Bend is kind of that way. It's not really quite a desert, but sort of like that too. The interior deserts, we mentioned the Gobi and the Sahara already. And then the polar deserts we mentioned. Mainly it's high pressure dominates there and the low temperatures. Low temperatures mean the air can't hold much moisture. Seasonality. So here's a great generalization. I'll almost certainly give you a test question or two on this. Most regions in the world have their low precipitation season in the low sun season. We're not that way. So what you know here is not really what much of the world is like. Much of the rest of the world has its low precipitation season the opposite time of the year as we do. So their winters are drier. Okay. Um, the reason is that convection is usually the biggest cause of precipitation in most parts of the world, especially the tropics, especially east coasts. And so whether it's Florida or Virginia and those kind of places in the eastern United States, they have lots of convective precipitation, thunderstorms, even Colorado, Kansas, Great Plains. And that's a summertime humid Gulf Coast moisture kind of flow that makes it so humid and wet there at times during the summer. Fog, couple, three kinds we'll look at. Advection. Advection is just where fog moves in from somewhere else. Classic example, San Francisco, the fog rolls in the afternoon or late morning even. Radiation fog is where you have strong radiational cooling and it forms a layer right along the surface. That's kind of classic winter time. And sometimes you've been up in a foggy mountain, like you're going to go skiing, it's all foggy there. That's an upslope fog. It's kind of like orographic, the same kind of concept we did earlier. Okay, that's what we have for this show. And I'll come back and we'll do some climate later on in this unit, climate change.